Kalian Singal Corporation makes 3 products which are flour, sugar and rice. The company used 3 machines in producing the products. The revenues for each of the products per kg are 4 ringgit for flour, 4 ringgit for sugar and 7 ringgit for rice. In producing flour, the operation hours needed for each of the machines are 1 hour, 2 hours and 8 hours. For the production of sugar, the machines need 7 hours, 1 hour and 4 hours, while for producing rice, it needs 4 hours, 7 hours and 1 hour respectively. There are 100 hours, 110 hours and 100 hours available for each machine respectively for operating in producing all of the products. X1 refer to product flour, X2 refer to product sugar, and X3 refer to product rice. For the first step, insert LP problem in Lindo. Key in the optimal solution and constraints as below. First, key in the optimal solution. Then, key in the constraints. Finally, end with the word AND. For the second step, choose Solve on the Lindo tab and click Solve. For the third step, it will appear, do range sensitivity analysis, then click Yes to get a result. Next, step 4, it will appear the Lindo solver status. Later, click Close to get the final result. In step 5, LP problem appears on report window. Here, we label the basic variable, optimality range, and feasibility range. For the first question, give the optimal solution for this LP. The answers are objective function value, which is Z, is 143 ringgit and 761 cent. Product 1 is 7.949 kg. Product 2 is 5.954 kg. Product 3 is 12.593 kg. The dual price machine 1 is 0.308 hours. Dual price machine 2 is 0.786 hours. And dual price machine 3 is 0.265 hours.
Okay, now let's see the Lindo printout. For box number 1, show the objective function value. Next, box number 2 show that the value of product 1, product 2, and product 3. While for box number 3, show that the value of dual price for machine 1, machine 2, and machine 3. Next, we go to the question number 2.1. If the available hours of time for machine 1 is increased by 20 hours, determine the optimal solution. The formula that used to determine the optimal solution is Z prime equal to Z plus 20 times dual price. We know that the objective function value is 143.76. while the dual price value for machine 1 is 0.308. Then these two values, we substitute it in the formula. Therefore, the new optimal solution is RM 149.92 cent. So, the conclusion for question 2.1 is since machine 1 increased by 20 hours, therefore, the dual price for machine 1 is 0.308. Then, 0.308 will multiply with 20. So, the new profit for machine 1 is RM 149.92 cent. Next, we go to the question number 2.2. If the available hours of time for machine 3 is decreased by 20 hours, determine the optimal solution. The formula that used to determine the optimal solution is Z prime equal to Z minus 20 times dual price. We know that the objective function value is 143.76. while the dual price value for machine 3 is 0.265. Then these two values we substitute it in the formula. Therefore, the new optimal solution is Rm 138.46 cents. So, the conclusion for question number 2 is, since machine 3 decreased by 20 hours, therefore, the dual price of machine 3 is 0.265. Then, 0.265 will multiply with 20. So, the new profit for machine 3 is Rm 138.46 cents. Next, we go to the question number 3. If the contribution of product 1 is changed to 5, what would be the new solution to the problem? The initial objective function is max equal to 4x1 plus 4x2 plus 7x3. Since product 1 is changed to 5, the new objective function will be max equal to 5x1 plus 4x2 plus 7x3. First, we must find the change of product 1. The change of product 1 or D1 is equal to 1, which is within the range. After finding the change of product 1, we use the formula Z prime equal to Z plus D1 times x1 to find the new solution. We substitute the objective function value, the value of change of product 1 and also the value of product 1 to the formula. Then we will get the new solution is Rm 151.71 cents. So the conclusion for question number 3 is, this show that the current basis variable remain optimal, which a new optimal solution is Rm 151.71 cents.
Okay, here's the window shows that the contribution of product 1 is changed to 5. Next, question number 4. If the contribution of product 3 is decreased by 1, what would be the new solution to the problem? Initial max equals to 4x1 plus 4x2 plus 7x3. New max equals to 5x1 plus 4x2 plus 6x3. Then we have to find the differences for D3, and then we put the value of D3 into the equation of Z prime equals to Z plus D3 multiplied by X3. We have to solve this equation and then we get the Z prime value, which is Rm 131.168. The conclusion: the current basic variable remain optimal with a new Z prime equals to 131.168 ringgit. The window shows that the variable for X3 have value 12.5925, which is in box 1. Meanwhile, in box 2, X3 variable shows the objective coefficient range. That's all from us, and thank you.